Welcome to Internet Infrastructure Explained.
Have you ever wondered what happens the moment you type a website address into your browser and hit enter? It feels instant, but behind that seamless experience, a complex global system is constantly at work, translating human-friendly names into machine-readable locations. This process, called domain name system propagation, isn't always as instant as it seems. Global DNS propagation is primarily influenced by several key factors, including time-to-live settings, caching mechanisms at various levels, and the inherent hierarchical structure of the DNS system itself. Understanding these elements is crucial to grasping why a change you make might not appear instantly everywhere. First, let's talk about the time to live, or TTL. This is a setting on your DNS record that tells a resolver how long it should cache, or remember that record before asking for an update. A shorter TTL means DNS changes propagate faster because resolvers refresh their information more frequently. However, a very short TTL can also increase the load on your authoritative name servers due to more frequent queries. Next up is caching. Everywhere from your local computer to your internet service provider's DNS servers, and even intermediate DNS resolvers, stores copies of DNS records. When you change a record, these cached copies need to expire before the new information is requested and used. Different ISP resolvers update their caches at varying intervals, which is a major reason why propagation appears uneven across the globe. Finally, the DNS system is a vast hierarchy. Changes start at your authoritative name server, then travel upwards to the top-level domain servers, and eventually across the global network of recursive resolvers. Each step in this chain takes time to update its records, and any delay at one point can ripple through the entire system. Geographic distance and network latency also play a subtle role, as it simply takes time for data to travel across the internet. So, what can you do with this knowledge? If you anticipate making DNS changes, you can proactively lower your TTL values a day or two beforehand. This ensures that caches expire more quickly, allowing your updates to propagate faster once you make them. You can also use online DNS lookup tools or propagation checkers to monitor the status of your changes across different geographic locations and ISPs. Just remember, these tools show you a snapshot, not a real-time global view. For high-availability services, some organizations employ advanced strategies like secondary DNS, which involves having multiple DNS providers serve identical records, or anycast DNS, which routes user queries to the nearest DNS server geographically. These methods enhance redundancy and can significantly improve query response times, indirectly influencing how quickly users in different regions access updated records. By understanding the interplay of TTL, caching behaviors, and the DNS hierarchy, you gain valuable insight into the underlying mechanisms that govern internet accessibility. This knowledge empowers you to manage your online presence more effectively, anticipate potential delays, and ensure a smoother experience for users worldwide, even when making fundamental changes to your domain's configuration.
If you love understanding how the web works, like, subscribe, and stay connected with us.